So here, also, if you look at the module one, they have asked you what is white space is just the spaces in between. Identifiers. So whenever you get something called as identifier, usually these variables, that is int x, if you give x will be an identifier. Okay. Float n means n will be an identifier. Class demo2 means demo2 will be an identifier. Now, there is one more term called as literals. Literals means this equal to 10 is there, right? All the values that you specify, that is a literal. This is a literal. Okay. This is a literal. Okay. Next, in case if they are asking you what is comments, comments means these like these sentences are used in the programming which will not be executing. Basically it will help you to understand what that statement is doing. So this is for my understanding. If I want to bookmark something, like I usually bookmark it in the website or something, and then if I have a book, I'll highlight it with a highlighter. This is more like a reading purpose. This will not be executed. So anything that you start with double slash for a single line comment. What if I have a multi-line comment? So multi-line comment will be something like this. This is just an example for multi-line comment. Okay, that's it. More than one line, start with the slash star or asterisk and then asterisk and then slash. End it with that. In between, whatever you write, that will be the comment. So usually you have this white space will be considered as separating two particular um, like equal to, if I have a is equal to some particular value here and here, this space might be there. Like you may give it or you may not give it, it will not affect so much. But when it comes to long and a, there should be some white space. Otherwise, it will think that it is something else. It is not a keyword. Okay. Now, everywhere when I'm telling keyword, you have to understand every particular thing which is highlighted by Java. That is this public, package, class, static, void, main, sorry, not main, int, float, long, all these things which is highlighted by it. No, all these things are called as keywords. Okay. This much, if you understand, it is more than enough. Now, one important thing is people do not know um, why we use this bytes, like what is the duty or how is it specified and everything. They do not know much. So I'll just give you one particular example. Let me take out a Excel sheet. Hmm. So what do you mean by 1 byte? So you have studied 1 byte is equal to 8 bits. So binary system, you have to come to the binary system. Whatever you write now, like 45, 432, all these are decimal, right? So if I have a value like something like this is a decimal value. And if I have to convert it into binary, it will be 1010 because highest is 1, lowest is 0. When somebody says 1 byte, what does it mean? It means you have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This much is occupied. Then what is the maximum decimal it can hold? Decimal in the sense, imagine last bit in binary. In a decimal system, minimum is 0, maximum is 9. In binary, minimum is 0, maximum is 1. And units place, tens place, hundreds place, and all multiple of 10 in decimal. Here, it will be more of 2 raised to multiple of 2, 2 raised to 0, 2 raised to 1, 2 raised to 2, and so on. Okay. Mm. Then the last digit, this is the 8 digit. Now, since I have started it from 2 raised to 0, so the last one will be 8th byte. 8th byte means this will be 2 raised to 7. This will be 2 raised to 6. Okay, something like this. Now, if you have to get the highest value in 1 byte, this is 1 byte because 8 bits, everything is a binary system. How to get the highest value? All these blocks should be filled with 1. Okay, if all these blocks is filled with 1, this is nothing but 1 into 2 raised to 7 plus 1 into 2 raised to 6 plus 1 into 2 raised to 5 and so on up to 1 into 2 raised to 0. So 2 raised to 0, anything raised to 0 is 1. 2 raised to 1 is 2. This will be 4. This will be 8. Because 2 raised to 2 is 4. 4 into 2 is 8. 8 into 2 is 16. Then it is 32. Then it is 64. And it is 128. So this decimal equivalent is nothing but sum of all these things is equal to sum of this whole stuff. 255. So maximum decimal value that you can store in this is 255. Okay, 1 byte means. Now, what do you mean by 2 bytes? Because short had 2 bytes, right? Then what is the maximum capacity that I can store in a short? If it is like, again, I'm going to keep it as 2. If it is 2 bytes, then it is having, each byte is having 8 bits. So first 8 bit, this 8 bit, let us say, is from 2 raised to 0 all the way up to 2 raised to 7. This is 1 byte. The second byte will start from 2 raised to 8 all the way from 2 raised to 8 to 2 raised to 15. Okay. So totally how many bits are there? This will be how much? 8 plus 8, 16 bits. 16 bits in the sense all 16 I have to put it as 1. Instead of that, what I'll do, I'll keep this block as 2. Okay, I know that this is 0 and so on. No? So what happened to this? So first bit will be 2 raised to 0, right? Second bit will be 2 raised to 1, so on up to 2 raised to 7. Okay, this will be 1 byte. The second byte will start from 2 raised to 8, 2 raised to 9, so on up to 2 raised to 15. Because it started with 0, right? So next 8 bits is from 2 raised to 8 to 2 raised to 15. Now, what is this 2 raised to 0, 2 raised to 1? If you want to know, you can use something called as power of 2 comma 0, which is 1. And if I just drag this, you will get to know. See this one. So you got that 128, 1, 2, 4, 8, 16, 32, and all the way up to 128. You had got it here, right? The same thing is here. Now the next byte, 2 raised to 8, will be 256. Then 512, then 1000 something, all the way up to 32,768. So if I want to store a positive value in a short, if I write uh, short x, let us say, what can x store? X can start from, if it is storing only the positive value, from 1 all the way up to this much. That means total capacity, how much the value can be, will be all the way up to here. That is 65,535. This is the maximum value x can have if it is storing only the positive values. If it is storing negative value also, then it will be 32,768 all the way up to 0, and then negative numbers, then minus 32,767. So that range will be there. This is what you mean whenever we say that we have a number which is short. Short can store only this much value. Now, if I want to store a little bit better, that means if I want to store a bigger number, then I'll go for int. Int will be what? 4 bytes. 4 bytes means 2 raised to 0 to 2 raised to 7 is 1 byte. 2 raised to 8 to 2 raised to 15 is second byte. Okay. In the same way, if I go with a third byte, no, third byte will be what? 16, 1, 2, 3, 4, 5, 6, 7, 8. Till here, this will be your third byte. Okay. And plus 8 will be nothing but 31. Okay, this will be the last bit. So if I just conclude here, you can notice that the numbers are increasing, by the way, exponentially. Okay, that is, if I am taking an integer x, okay, what is the maximum positive value it can store? I'll tell you. Means what is the maximum positive value that you can store in an integer value is this much. More than this is also not sufficient. You won't have to have a bigger number than this, probably for four numbers and all. If you notice, no, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits are there, but your phone number starts with 8, 9, and all the stuff. So those things will not be included here. So what we can do, we can use long, because what happens with long? Long we have 8 bytes. 8 bytes means what? 2 raised to 0 to 2 raised to 63, because mm, 8 into 8 is 64. So if we are starting with 0, 2 raised to 0 to 2 raised to 63. So bigger number, okay, is possible there. So phone numbers and all, it's better that we use long, okay, because it is storing many values. If it is very simple calculation where we have numbers, we know that it will not exceed 1000, it will not exceed 10,000, then go for short. Okay, if there is a number which you want to store, but it is like not too small, not too big, then we are going to go ahead with int, something like this. Okay, this is important.